Hello students, welcome back. So we have completed exercise 21, isn't it, in our previous videos. So we'll start exercise 22 from today onward. So this is exercise 22A, heights and distances, okay, and I have already written question number 1 of exercise 22A, and we'll begin this chapter from this video. Okay, so while doing the questions from this chapter, we will come across two terms. That is, number 1 is angle of elevation, and number 2 is angle of depression. Both are same thing, okay, but slightly different. So we need to understand this. Suppose this is a tower or a lamp post, and this is the ground. This is the ground and this is the tower. Okay, if you are observing from the ground, which is in the line with the base of this tower, okay, the foot of this tower, if you are observing from the ground which is in a line to the base of this tower to the top of the tower, if you are looking at the top of this tower, the angle that you make with the base, okay, with the baseline, is called angle of elevation. This angle is called angle of elevation, which means when you look upward, the angle which is formed is called angle of elevation. And angle of depression is, suppose this is a tower, and if you are here, okay, and if you look at the foot, at the ground which is in a line to the foot of the tower, okay, and if you say this like this, the angle which makes parallel, this line is parallel to the base, isn't it? This line is parallel to the base, and the angle which is made here is called angle of depression. Angle of depression. And this angle of depression will be equal to angle of elevation, because this line and this line are parallel to each other, and this line is a transversal, isn't it? So suppose if I name these lines AB and CD, AB and CD are parallel to each other, and suppose this is EF. EF is a transversal, so this angle BEC and angle CFE, these two angles will be equal to each other. These are called alternate angles, isn't it? So angle of elevation and angle of depression are actually the same thing, okay. The value will be same, but we name this differently because just from the point of observation. If you are looking from the foot of the ground to the upward, then the angle which makes is called angle of elevation, and if you are at a height and look downward, then the angle which is formed is called angle of depression. Nothing different, okay, the same thing. So let's do this question. Question number 1. So this is question number 1. The height of a tree is √3 times the length of its shadow. Find the angle of elevation of the sun. Okay, the height of a tree. So this is a ground, this is a tree, okay, and sun is here, okay. You don't have to draw the sun, and due to the sun, you know, the shadow is made here, isn't it? This is the length of the shadow of the tree. This is tree, this is tree. Suppose this is A, this is B, this is C. AB is tree and BC is the shadow of the tree, okay. Shadow means the rays from the sun is being blocked by the tree, isn't it? So from here afterward, the rays are not blocked, so no shadow is formed. So the rays of the sun which are blocked by the tree forms a shadow here, isn't it? So this is the shadow. BC is the shadow, okay. BC is the shadow and AB is the height of the tree. So according to the condition or according to the question given to us, the height of a tree is √3 times the length of its shadow, isn't it? So if the length of the shadow is x meter, okay, suppose if we consider x unit, so let the length of the shadow of the tree is x unit. If the length of the shadow is x unit, length of the shadow of the tree is BC, isn't it? BC is x unit. This is BC is x unit. Then according to the question, height of the tree is AB, isn't it? AB is the height of the tree. AB equals to √3 times the length of the shadow, isn't it? The height of a tree is √3 times the length of its shadow, means √3 times means into √3 times the length of the shadow, √3 into x. √3 into x means √3x, isn't it? √3 into x means √3x. This is the length of the tree or the height of the tree, okay? This unit is the height of the tree. So we are asked to find this angle of elevation. Find the angle of elevation of the sun, means we are asked to find this angle. So you are observing from this point, so we are asked to find the angle of elevation, this angle, okay? And if we draw a parallel line parallel to this base, the angle of depression which will be formed here will be equal to this angle of elevation, okay? So no need to mention that. So suppose the angle of elevation is theta. Let the angle of elevation that is angle ACB, isn't it? ACB, make sure C comes in the middle, okay? ACB equals to theta. ACB means angle C is theta. So since according to condition, since we know that tan theta equals to perpendicular upon base, isn't it? We know the perpendicular AB and base BC, so we must apply tan theta because tan theta is perpendicular upon base. In most of the questions from height and distances, okay, we have to apply tan theta only. In some cases we rarely apply sin theta and cos theta, but in most of the cases we apply tan theta, okay? So tan theta is perpendicular upon base, isn't it? So if we are considering this angle, which will be the perpendicular? Perpendicular will be AB and base will be BC, isn't it? So perpendicular is AB and base is BC. So tan of theta means this angle, okay, equals to perpendicular AB. AB is, what is AB? AB is √3x. So we write √3x, and BC is x, isn't it? So we cancel out this x and x. Okay, now let me continue here. Tan theta equals to √3, isn't it? Or tan theta equals to √3. √3 means, what is the value of √3? Or tan theta equals to tan 60 degree, isn't it? The value of tan 60 is √3. So instead of √3 you can write tan 60. Now what we do is, we cannot cancel tan and tan, okay? Tan and tan cannot be cancelled because tan is a trigonometrical identity. So we leave tan from both the sides, therefore theta equals to 60 degree. Okay, therefore the angle of elevation equals to 60 degree. Okay, I hope you got this. Now let's do question number 2. Okay, now let us do question number 2. So this is question number 2 of exercise 22A. Okay, the angle of elevation of the top of a tower from a point on the ground and at a distance of 160 meters from its foot is found to be 60 degree. Find the height of the tower. Okay, let us understand this question first. So this is a tower and this is the ground. Okay, Now from the foot of the tower 160 meters away there is a point. Okay, 160 meters away from the foot of the tower, 160 meters away, 160 meters away from the foot of the tower there is a point. 160 meter distance from this foot of the tower and this point is 160 meter. It is found to be 60 degree. When you see the top of the tower, the angle of elevation from this point is 60 degree. Okay, this is the point 160 meters away from the foot of the tower, and from this point when you observe the top of the tower, it is seen that the angle of elevation is 60 degree. Now we are asked to find the height of this tower. Okay, suppose this is A, this is B, this is C. This is a right angle triangle, right angle at B, isn't it? So we are asked to find the value of AB. AB means the height of the tower. Okay, since let us write AB equals to height of the tower, height of the tower. See, we are assuming AB is the height of the tower. Okay, okay, BC equals to base of triangle ABC. Well, let's not write this. Okay, BC equals to 160 meter and angle ACB, ACB is 60 degree, isn't it? Angle C should come in the middle. Okay, ACB means this angle C. Angle C is 60 degree. Now we are asked to find AB, isn't it? So we apply tan theta here also, because base is given to us and perpendicular is being asked, isn't it? In triangle ABC, right angle triangle ABC, since tan theta equals to perpendicular, that is AB upon base BC. Okay, or tan theta means 60 degree, isn't it? Tan theta is 60 degree. Tan 60 degree is equal to AB. AB is not given to us, we are asked to find AB. AB upon BC is given to us, that is 160, isn't it? BC is 160. Or now we put the value of tan 60 degree. Tan 60 degree means root 3 equals to AB upon 160. Okay, let's continue. Now we can cross multiply this, isn't it? 160 into root 3. Therefore AB equals to 160 into root 3 is 160 root 3. So this is the answer, isn't it? 160 root 3 meters is the height of, this is meter, okay, height of the tower. The height of the tower is 160 root 3 meter. You can put the value of root 3. Now 160 into the value of root 3 is value of root 3 is 1.732. okay, we must remember this. The value of root 3 is 1.732. 1.732. Now we will multiply these two numbers and write here. Okay, 1.732 into 160. Okay, we don't multiply with 0, we will put 0 afterward. Okay, 6 2s are 12, 6 3s are 18, 19, 6 7s are 42, 43, 3, 4 in hand, 6 1s are 6 plus 4, 10, 1 2s are 2, 1 3s are 3, 1 7s are 7, 1 1s are 1. Now 2, 9 plus 2 is 11, 3 plus 3 is 6, 7, this comes 7, 1 1 2. When you add these two numbers you get this. Now we have 0 also, so we must put 0 here. This 160, isn't it? This is 160, so we put 0 here. Now before how many digits there is a decimal point? 1 2 3. So 1 2 3, we put a decimal point here. This means 277.12. okay, so we don't write 0, because 0 has no value after decimal point. But if 0 is like this, if after decimal point, if 0 is written before a number, then this 0 cannot be ignored, okay? This 0 has some value. But if you write 0 here and no number afterward, that means this 0 has no value, so we don't write this 0. This means 277.12 meter is the height of the tower, okay? We are asked to find the height of the tower, isn't it? Therefore, the height of the tower is height of the tower, isn't it? Tower, yes, tower. The height of the tower is equals to 277.12 meter. This is the answer for question number 2. Now let's do question number 3. Let us do question number 3. A ladder is placed along a wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall and the ladder is making an angle of 60 degree with the ground. Find the height up to which the ladder reaches. Okay, so this is a wall, this is the ground. Okay, now a ladder is placed in such a way it is resting on the wall. Now this is the ladder. Okay, suppose this is A, this is B, this is C. AB is the ladder, BC is the distance of the foot of the ladder from the foot of the wall, and AB is the wall. Okay, a ladder is placed along a wall such a way that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall. Means BC means 2.4 meter. 2.4 meter. The distance of the foot of the ladder from the foot of the wall is 2.4 meter. BC. The foot of the ladder is 2.4 meter away from the foot of the wall. Okay, BC is 2.4 meter. And the angle of elevation is 68 degree. Angle that makes with the ground is 68 degree. Now find the height up to which the ladder reaches. We are asked to find AC, height up to which the ladder reaches. Okay, AC, we are being asked to find the height up to which the ladder reaches. Okay, AC. Let the height up to which the ladder reaches AC equals to x meter. Okay, suppose AC equals to x meter. So now BC is given to us. BC is 2.4 meter, 2.4 meter, isn't it? And angle AC, ABC, this angle, isn't it? ABC, this angle is 68 degree. ABC equals to 68 degree. Now in triangle ABC, tan of angle ABC, this angle, isn't it? Tan of angle ABC, angle B, tan of angle ABC equals to perpendicular is AC, perpendicular upon base is BC. Now tan of angle ABC is given to us 68 degree. Angle ABC is 68 degree, angle B is 68 degree. Tan of angle 68 degree equals to AC upon BC. AC is perpendicular, which we are being asked to find. AC is x, isn't it? So BC is the distance of the foot of the ladder from the foot of the wall, that is 2.4. Okay, so now we put the value of tan 68 degree. You can find the value of tan 68 degree in page number 455. Okay, tan 68 degree is 2.4751. 68 degree, tan 68 degrees 2.4751. 2.4751. You don't need to memorize all this. Okay, this table will be provided to you during examination. Equals to x upon 2.4. Or now all we need to do is we multiply these two numbers, that will be the value of x, isn't it? This 2.4 can be multiplied with this because this there is an equal to sign in between them, so we can cross multiply this number. So 1 into x is x, 1 into x is x, equals to 2.4 into 2.4751, 2.4751 into 2.4, isn't it? So let's multiply this, 2.4751 into 2.4. So 4 ones are 4, 4 5s are 20, 0, 2 in hand, 4 7s are 28, 29 30, 0, 3 in hand, 4 4s are 16, 17 18 19, 9, 1 in hand, 4 2s are 8, 9, isn't it? 2 ones are 2, 2 5s are 10, 2 7s are 14, 15, 2 4s are 8, 9, 2 2s are 4. So this is 4, this is 2, this is 0, 9 plus 5 14, 4, 9 9 18, 19, 1, 4 1 5. So before 1 2 3 4 and 5, here you can see a decimal point is before 1 2 3 4 digit, and here you can see a decimal point is before 1 digit. So altogether 1 2 3 4 5. So 1 2 3 4 1 2 3 4 5. So we need to put decimal point here, or x equals to 5.94024, 94024 meter. Therefore the height of the, okay, we don't need to write all this because we have already mentioned the height up to which the ladder reaches is x. X means this means the height where the ladder reaches is 5.94024 meter. Okay, I hope you got this. Now let's move on to next question. Question number 4. Let's do question number 4. Two persons are standing on the opposite side of a tower. They observe the angles of elevation of the top of the tower to be 30 degree and 38 degree respectively. Find the distance between them if the height of the tower is 50 meter. Okay, so let's understand this question first. So this is a tower and this is the ground. Two persons are standing in the opposite sides of the tower. Okay, suppose this is the point where the first person stand and this is the point where the second person stand. Now both of them looked at the top of the tower. So this is the top of the tower. Yeah, this is the top of the tower. Okay, now they observe the angles of elevation of the top of the tower to be 30 degree and 38 degree. When this person observed the top of the tower, the angle was 30 degree, and when this person observed the top of the tower, the angle of elevation is 38 degree. So we are asked to find the distance between them, means distance between this person and this person. Okay, if the height of the tower is 50 meter, height of the tower given to us is 50 meter. This is the height of the tower, isn't it? So let's assume this as A, B, C and D. There are two right angle triangles. Okay, two right angle triangles, A, B, C. This is a right angle triangle, right angled at C, and A, C, D. Okay, this is a right angle triangle, right angled at C. Now we are asked to find BD, isn't it? Distance between the two people, B and D. B is the place where the first person is standing, and D is the place where the second person is standing and observing the tower, isn't it? And we are asked to find BD, means distance between these two persons. So first we find BC and then we find CD, and we add up BC and CD, so we will find BD, isn't it? So I hope you got this. Now let's solve this question. So in triangle ABC, okay, and AC is the height of the tower. AC is height of the tower, which is equal to 50 meter. isn't it? And angle ACB, not C, ABC, okay, ABC, angle B should come in the middle, okay, ABC, angle B should come in the middle. ABC is 30 degree, ABC is 30 degree, so we will find BC, okay, BC. Now since tan of angle ABC, angle ABC means theta, isn't it? Tan theta equals to perpendicular upon base. What is perpendicular? Perpendicular is AC upon base. Base is BC. BC. Okay. So tan angle ABC is given to us 30 degree equals to AC. AC is given to us 50 upon BC is not known to us, so we write BC here. So tan 30 means 1 upon root 3 equals to 50 upon BC, or BC into 1 is BC, we cross multiply this, BC into 1 is BC equals to root 3 into 50 is 50 root 3, isn't it? So let me continue here. BC equals to 50 into root 3. This means BC equals to 50 into 1.732, isn't it? The value of root 3 is 1.732. okay. Now let's multiply this. 5 2s are 10, 5 3s are 15, 16, 5 7s are 21, 35, 5 7s are 35, 36, 5 1s are 5, plus 3 is 8, and this 0 comes here, so we put decimal point before 3 digit, isn't it? 1 2 3, there is a decimal point, so 1 2 3. This means 86.600, we don't write, okay. BC is 86.6 meter. BC, we found BC. Similarly we'll find CD, and after that we'll add up, okay. Again in triangle ACD, this triangle, okay, ACD, tan of angle ADC equals to perpendicular is AC. AC is common to both the triangles, this and this, isn't it? ABC and ADC. So this is common side for both the triangles. So that is perpendicular. Perpendicular tan ADC is perpendicular upon base. Perpendicular is AC, isn't it? Upon base is CD, or tan of angle ADC is given to us. ADC is 38 degree. Tan 38 degree equals to AC. AC means 50. We write 50 upon CD. We are asked to find this, isn't it? Now we will write the value of tan 38. What is the value of tan 38? You can find the value of tan 38 here from page number 454. Okay. Natural tangents. Tan 38 is 0.7813. 0.7813 equals to 50 upon CD. Now we bring CD here, we just cross multiply. CD comes to the numerator, this number goes to the denominator, or CD equals to 50 upon 0.7813. 0.7813. CD is 50 upon 0.7813. So we write CD equals to 501234. There is a decimal point before 4 digit numbers, isn't it? So we write 4 zeros. 1 2 3 4. 1 2 3 4. This 0 was already here. We put 4 zeros. 1 2 3 4, because we will remove decimal point from 4 digit. Okay, 1 2 3 4 7813. So if we divide this, we get approximately 63.99 and so on. Okay, this means this can be assumed as round up 64. meter. Okay, if we divide this number by 7813, we get 63.99 and so on. This means 64. Okay, close to 64, so we assume it as 64. CD is 64 meter. Now let me erase this. Okay, now we are asked to find the distance between the two persons, isn't it, B and D. Therefore distance between the two persons standing opposite to the towers. Okay, opposite to the tower, distance between the two persons equals to BD, isn't it, BD equals to BC plus CD. BD is BC plus CD, isn't it? So what is BC? Oh, BC is 86.6. 86.6 plus CD is 64. 63.9, and you can write this also. Okay, approximately. So this becomes 4 plus 6 is 10, 8 plus 6 is 14, 14 plus 1 is 15, isn't it? 4 plus 6 is 10, 8 plus 6 is 14, plus 1 is 15.6, 150.6 meters. Therefore the distance between the two persons BD equals to 150.6 meters. I hope you got this. Now let's do question number 5. 5. A kite is attached to a string. Find the length of the string when the height of the kite is 60 meter and the string makes an angle 30 degree with the ground. Okay, so let's understand this question. Suppose this is the string and the kite is flying here. Okay, and this is the ground, and the height of the kite from the ground is this. This is the ground and this is the place where the kite is flying. This means the kite is flying at this height from the ground, isn't it? So this is A, B, C, and this is the length of the string. So what is given to us? Find the length of the string. So we are asked to find AB, length of the string AB, when the height of the kite is 60 meter. The kite is at the height of 60 meter from the ground, isn't it? 60 meter. AC is 60 meter. This is the height of the kite. Okay, and the string makes an angle 30 degree with the ground. This string, this is the string, isn't it? So a string makes an angle 30 degree with the ground. So we are asked to find this. Okay, hypotenuse AB, hypotenuse AB, and perpendicular is given to us. Sin theta, isn't it? Sin theta means perpendicular upon hypotenuse. Okay, we will apply sin theta here. Now in triangle ABC, AC equals to height of the kite equals to 60 meter. This is given to us, isn't it? So angle ABC equals to ABC equals to 30 degree, and AB equals to length of the string. This is what we are asked to find, length of the string, isn't it? This is what we are asked to find, AB, length of the string. You are flying a kite from this point B. The kite is flying here. The height of the kite from the ground is 60 meter. We are asked to find this length of the string. Okay, and the angle that a string makes with the ground is 30 degree. So since sin theta, sine of angle ABC, we apply tan theta when perpendicular and base are given to us, or perpendicular is given to us and base is being asked. Okay, when we relate between perpendicular and base, we apply tan theta. Now we don't apply tan theta here, we apply sin theta. because perpendicular is given to us and hypotenuse is being asked, isn't it? So we apply sine theta, because sine theta means perpendicular upon hypotenuse. What is perpendicular? Perpendicular is AC and hypotenuse is AB. AB, isn't it? AB is hypotenuse. So sine of ABC is 30 degree. So sine 30 degree equals to AC is given to us. What is AC? AC is 60 upon AB. AB is not given to us. We are asked to find AB, isn't it? Now what is the value of sine 30? Sine 30 is 1 by 2, isn't it? So this is 60 upon AB. Or let me continue here. AB into 1 is AB. We cross multiply this, equals to 2 into 60. 2 into 60 is 2 6 are 12, isn't it? 2 6 are 12. Now this 0 comes here, 120 meter. Therefore the length of the string, equals to 120 meter. Okay, when the length of the string is 120 meter, the height of the kite is 60 meter. Okay, I hope you got this. Okay, this was for today. I'll continue the remaining questions in the next video. Thank you.